So this video, we're going to also look at dividing polynomials, but we're going to look at what happens when we divide them by a binomial or greater. So binomial meaning two terms or more than two terms. So x squared plus 12x plus 35 divided by x plus 5. Well, now we can't just do the canceling and the application of our exponent rules because of the fact that there's addition between the x and the 5. So we have to have a totally new approach. And so what we're going to do is we're going to go back to something that you've learned about a long time ago and probably haven't had much reason to use in a very long time. And that is, if I was to divide a couple numbers like that, without a calculator, you would use long division. So we're going to remind ourselves of how to do long division with numbers. All right. So you might remember the first thing you do is you try to put the thing that you're dividing by into as few digits as possible that you see here. So you'd say, um, how many times can 18 fit into 34, right? Well, 18 only goes into 34 once because 2 times 18 would be 36, which is a little too big. So we would say 18 divides into 34 one whole time, and you're going to put that one right over the last digit of 34. Then you'll recall you go 1 times 18 and put that there, and then you subtract it off. So you're saying, okay, 18 and, do a little bit of arithmetic here. 14 minus 8 is 6. 2 minus 1. So you have a remainder of 16. Now what you're really doing is see how this 1 is in the hundreds place up here? So you're saying 18 fits into 3,467 100 times. And so when you're subtracting off 18, you're really subtracting off 1,800 from the whole thing. But uh, rather than write out all those extra digits, we just say 34 minus 18 is 16. And then you'll recall that you drop a 6, drop the next digit, and then you say, how many times does 18 fit into 166 evenly? This time it fits in a lot. Fits in 9 times. And so you do 9 times 18, and 9 times 18 is 162. And you just keep repeating this process, getting a remainder and dropping down the next digit until you run out of digits. 18 goes into 47 twice, so 2 times 18 is 36. And so you end up with a remainder of 11. So 192 remainder of 11 is our answer. Okay, so we're not going to be doing a whole bunch of this, but what we will be doing is applying the principles that we use in the long division algorithm to dividing polynomials. So what we're going to do is we're going to put the polynomial we're trying to divide inside of that same long division symbol that we used over here. And just like we put 18 outside of that, we're going to put the thing we're trying to divide by outside here. Now, what we did was we said we kind of paid attention to the front end of the number 3,467. And we said, what times eight, how many times does 18 fit into 34, right? And we're going to say something similar here. And we're only going to pay attention at first to the x squared in terms of figuring out what I want to put up top here. So here's what we're going to say to ourselves. What would I multiply x by in order to create x squared? Well, the answer is you would multiply by x, right? So I'm going to put an x up above the x term here. In the same way I put the 1 right above the 4, I'm going to put the x above the x term. Then I'm going to multiply through. I'm going to say x times x is x squared. But then I'm also going to do that with the plus 5 term. So x times 5 is positive 5x. Right now, so that was like our 1 times 18 step that we did. But then what did we do after that? We subtracted off the 18. So we'll do the same. It's very important you put parentheses around that for the subtraction, because not only are you subtracting off this term, but you're also subtracting this term. So it'll be x squared minus x squared is 0. And then 12x minus 5x would give me 7x. Over here, after we finished subtracting and got this number, then we dropped the next digit. So what we're going to do with this division is we're going to drop the next term. All right. And again, I'm going to not pay attention to the plus 5, not pay attention to plus 35. I'm just going to ask myself, what times x would give me 7x? Well, of course, 7 times x would give me 7x. So again, I multiply through 7 times x is 7x. 7 times 5 is 35. So we'll subtract those. 7x minus 7x is 0. 35 minus 35 is 0. So what I have here is an answer of x squared plus 12x plus 35 divided by x plus 5 is equal to x plus 7. And that's my answer. All right, let's do another example. So we're going to divide 6x squared plus 7x minus 7 divided by 2x minus 1. So the 6x squared plus 7x minus 7 goes there. And then 2x minus 1. All right. Now, again, when deciding what to put up top here, I'm not going to worry about the minus 1. I'm not going to worry about the plus 7x or the minus 7. I'm just going to look at 2x and at 6x squared. So just focusing in on those two right at first. And so I ask myself, what do I multiply 2x by in order to produce 6x squared? The answer would be, in order to produce 6, I need to take 2 and multiply it by 3. And then to produce x squared, I'm going to have to multiply it by x. So now I go ahead and multiply through, not only to the 2x, but the minus 1 as well. So 3x times 2x is 6x squared. So we're always trying to produce the exact same term under this one, right? When we're deciding what to put up here. Then 3x times negative 1 is minus 3x. Now, if this one's a little tricky. 6x squared minus 6x squared gives me 0 here, which is good. But now notice 7x minus negative 3x. Well, we understand that minus and negative, I'll just go ahead and write it up here, always turns into plus a positive. So that should give me 10x. So just be careful of the minuses and the negatives showing up. Drop the next term. Now I ask myself, what do I multiply 2x by in order to produce the 10x that I see down there? So I'm really just focusing on this and this for the moment. And the answer is I need to multiply 2x by, oops. Sorry, I thought I was grabbing the right color there. By positive 5, right? 5 times 2x would give me 10x, but then I also multiply the minus 1. 5 times negative 1 is negative 5. And we'll subtract that. And once again, be really careful. Negative 7 minus negative 5. So it's never a terrible idea to Do a little scratch work on the side. So that's going to be -2. Okay, now this is different than the last problem. The last problem, we got a remainder of 0. So we were able just to say this is equal to the result up here of x plus 7. So we want to write something similar. So it'll be 6x squared plus 7x minus 7 divided by 2x minus 1. Well, we want to be able to write this 3x plus 5, but then what do we do about this remainder? Okay. To answer that, let's go back to the previous page and go back to our numerical answer. So over here we had 192 with a remainder of 11. But what I want to remind you of is that um, another way that you would write something like this is to think about mixed numbers. Another way of putting it would be this, that it is 192 and 11/18, right? Whatever your remainder is divided by the divisor. So this is going to be our inspiration for kind of what we're going to do when we do get a remainder with these polynomials. So I'll put my remainder over the thing I was dividing by. So we have -2 over 2x minus 1. So here's how you'll write your answer when you have a remainder. All right, let's look at another example where we're dividing by a binomial. One of the things you will run into is that sometimes you won't see every single term that might show up or that you might expect to show up when you have something like 9x cubed. So, first of all, as we've said often, it's helpful a lot of times to put things in descending order. You definitely want to do that when you're doing this, what we call polynomial long division. So put the x cubed term first, reorder all that. But the second thing that you'll want to do is if you ever are missing a term, notice how, you're kind of expecting to see an x squared there. But if it's missing, then you want to go ahead and put one in there anyway as a placeholder. All right. So always put a placeholder in if there is a type of term that is missing. So when you write out this long division here, 9x cubed plus 0x squared minus x plus 5, 3x plus 2. All right, so now we're going to ask ourselves, what do I multiply 3x by in order to produce 9x cubed? And so, of course, the answer is 3 times x squared is what I'd multiply by here. So notice the importance of having this placeholder because it gives me a place to put that, right? I need to put it over the x squared term. So now I actually have one. So 3 times 3 is 9. X squared times x is x cubed. Then I do the same thing for my 2. 3x squared plus 2 would be plus 6x squared. And again, I have some place to put this 6x squared now. So 0 minus 6 would be -6x squared. Drop down the next one. All right, so now I'm saying, what do I multiply 3x by to produce -6x squared? So that would be minus 2x, right? -2x times 3x would give me -6x squared, and -2x times 2 would give me -4x. And again, so important to put parentheses there when you're doing that subtraction. -6 minus -6 is 0. Again, never hurts to do a little scratch work on the side to make sure you get this right. Oops, that's an X, sorry. So 3X, that's what I get here. Drop the 5, and then 3X times 1, right? That's all I need is a 1, but you need to put that here, right? 1 times 3X is 3X. 1 times 2 is 2. So we can subtract that off, get a remainder of 3. So our answer here is, so we had originally 5 minus x plus 9x squared, 9x cubed, excuse me, over 3x plus 2. That's going to be 3x squared minus 2x plus 1 plus the remainder, which is 3, over 3x plus 2. So that's how I would write that answer. All right, just two more examples here. I've kind of shown you the different things that pop up when you're working on these problems. So for these two, this would be a good time to hit pause, try the two yourself, and then come back and check on what my solutions are. All right, so for this first one, we are going to need some placeholders for sure. There's no x squared term, there's no x term. So we first understand that we need two placeholders. So x cubed plus 0x squared plus 0x minus 1 underneath, and then x minus 1. So we know x squared times x will give me x cubed. X squared times negative 1 is minus x squared. But because we are doing 0 minus negative x squared, it's actually a positive x squared as a remainder. Even though it kind of seems silly, you can go ahead and drop this down. Okay. And then we'll say to make x squared, you just need to multiply by x, right? X times x is x squared. X times negative 1 is negative x. And again, 0 minus negative x is plus x, or positive x as a remainder. And then x times 1. And 1 times negative 1 is negative 1. And so this is a nice one. We actually end up with a remainder of 0. So x cubed minus 1 over x minus 1 is equal to x squared plus x plus 1. No remainder at all. And then the second one, what makes it challenging is that it's just so darn long. But the good thing is it doesn't have any, missing terms. So when I go to put it in the long division notation, no placeholders are necessary. So produce, in order to produce 3x to the fourth, I know that I'm going to have to multiply x by 3x cubed. So 3x cubed times x is 3x to the fourth. 3x cubed times negative 3 gives me negative 9x cubed. Again, here's where we can easily make mistakes, so be careful. Subtract, put parentheses around it. So negative 11x cubed minus negative 9x cubed is the same as negative 11x cubed plus 9x cubed. So the result would be negative 2x cubed here. Bring the next one down. I need to multiply by negative 2x squared to produce negative 2x cubed, and then negative 2x squared times negative 3 plus 6x squared. So I have 2 minus 6 is negative 4x squared here. Drop down my 10x. So x times negative 4x gives me negative 4x squared. And negative 4x times negative 3 is plus 12x. So negative 2x is what's left there. Almost done. Bring down the plus 6. So minus 2 times x is negative 2x. Negative 2 times negative 3 is positive 6. So another one that doesn't have a remainder involved. So that's nice. So my answer is what's up on the top there, 3x to the fourth minus 11x cubed. Oh, excuse me, not minus 11x cubed. Let's try that again. 3x to the third. I was copying down the original problem. Minus 2x squared minus 4x minus 2. And that is my final answer.